Yes, please. Yes, please solve this problem. Aram se understand the mechanism here. This rod is hung by two strings. And see the center of the rod, it is uniform rod. The string B is cut. And they said the magnitude of the acceleration of the center of C of the rod is AC. Find the angular acceleration of the rod and acceleration of its end A. First try to understand the mechanism here, then things will become clearer. As it is in equilibrium. Hello?
Yes, sir.
Yes, sir.
So we know it is in equilibrium. See, let us represent whatever we can understand from this diagram initially. Okay, then that helps us to understand the mechanism easier.
Yes.
So write the condition for equilibrium. And then see how we can analyze this. So condition for equilibrium have two tensions here, tension T1 and tension T2. And the weight vector is down. Okay. So this point is A, this point is C, and this point is B. So if I take the moments about A, then this is the perpendicular distance. We call this point as B dash and this point as A dash.
Yes.
So if I take the moment about A, then the clockwise moment will be W into AC, A dash C.
Yes.
And this will be equal to T1 into B dash A dash. Correct?
Yes.
So this will ensure that the summation M is equal to 0, and obviously W will be equal to T1 plus T2. So this is how the equilibrium condition is established. Okay. Now the moment we cut off T1, that is the string is cut means T is cut off. Then what at that instant, one thing you should know, as soon as they have asked at the instant when that is cut, at the instance when the string is cut, what all happens? One thing is force immediately acts, and as a consequence of force there is acceleration, torque and acceleration will be there.
Yes.
But there will be no velocity. V is 0, omega is 0.
Yes.
The moment you cut it. Okay, keep that in mind. So that is one more thing that we can understand from this. And what else have they told? They have told that the acceleration at C will be AC. They have told it is AC. Right? So these are the things that they have told. So therefore, what do we expect? As soon as T1 is cut, what will happen to the rod? What will happen to the rod? Just try to understand this mechanism.
Soon after red is cut, sir, A will become ICR.
Wait, before A will become ICR, what will first see? We will identify ICR later on, but what will happen to the what are the forces? What are the forces, in what direction they will be, etc., etc., all that we'll have to see.
Yes, sir.
Okay, because we'll have to see all that.
Force W will act, sir.
Force W will act.
Like it will become unbalanced force, sir. So it will start.
Okay, fine. So we will start with that.
About B we can take torque.
So force W will act.
Yes, sir.
Okay, and you want to make A ICR.
Yeah, it's
Okay, you want to make ICR. Okay, so if you want to make A ICR, then you will have the, if you make A ICR, then see, for us, the analysis for us was that whenever we had handled the rods and all, no, right? So if we said this is going to be alpha, then for us one thing was sure, we had the horizontal component alpha r, okay,
Yes.
and we had the alpha r, and we used to have this omega square r.
Omega square.
So there was centripetal force and tangential force that was acting. Okay, these are the two vectors that are acting. So now what will this force do? See, there is already one more force here. There is one tension. This tension will not come down, but this is there. This force is acting. Okay, so this force is acting, but this tension will also be there.
Yes, sir.
So then, see, this rod is like this. As soon as this is cut, what happens to this end of the rod?
It will remain there. It will start moving, sir. Like
You mean to say this is the rod,
Yes.
and are you expecting this rod to simply go down like this?
So momentarily it will remain at rest. Then
Momentarily afterwards also you feel it will go like this?
no sir, like it will bounce.
How? Huh? What?
It will like it bounce.
Bounce?
Like impulse to the
sir, first it will come down, sir.
No. It will come down only. It will only, you mean to say this will only come down like this?
Sir, it will come like it will start
How did he say that?
like this curve oscillating.
So now, what it says, will this point A be there only? Will this point A get displaced or it will be there? This point A, will it be there only or it will get displaced?
It is fixed.
No, see, now be careful. It is a string. This is a string. This is not a rod.
Yes.
Yes.
It's a string. It is not a rod. It is not a permanent fixture.
It will go up, point
Go up.
little bit like. It will little bit go up and again.
Why it will go up?
So since that, if we see this point is only tension.
No. You are horribly wrong. You are horribly wrong. See, if you say this point has to go up, see, it's a string, man.
Yes.
See, the tension in the string will be there as long as there will be force, as long as the string is taut.
Yes.
Understand? Unless you forcibly push that point A up, there is no force. There is no force to push that up. See, if there was some cantilever here or something like that, then it would have taken that as a fulcrum and pushed it up. It would have taken that as a fulcrum and pushed it up. But here, that is not the situation. So first, try to tell what happens to this point A. You are telling that this rod will rotate.
This way.
This is for sure.
Clockwise.
Clockwise, it will rotate. Now, will this cause this point A to move horizontally? Vertically, at least it will not move.
Okay. Yes, sir.
Vertically, at least it will not move. There is no vertical acceleration.
Yes, sir.
There is no vertical acceleration.
Yes, sir.
Yes.
Okay.
Yes.
So now, why don't you do like this?
Sir, it will
See,
point in.
see, now, why don't you see like this?
Yes, sir.
See, this is my hand. Supposing there is a force which pulls it down like this.
Yes, sir.
Okay. Now, see, if you can split this vector into two components. If you can split this vector into two components, then this is theta. So this should also be theta. So this component will be W cos theta. And this component will be W sin theta.
Yes, sir. Yes, sir.
Split that into two components. Let us see, as a consequence of these two components, what happens. Because we are sure it will rotate. So this W cos theta about this point can cause the rotation.
Yes, sir. Yes, sir.
and this W sin theta will act like this. W sin theta will act like this. Now again this W sin theta, you split it into two components. Okay, so what will happen? This will be W sin theta into cos theta, and this will be W sin theta sin square theta. Okay, this is possible, no?
Can you repeat?
See, now I am splitting this weight W into two components, W cos theta and W sin theta. Is that clear?
Yes, sir.
So this W sin theta will push the rod in this direction. Okay,
Yes,
so
sir.
W sin theta. Now this W sin theta, I will again split it into two components. So this component will be W sin theta cos theta, and this component will be W sin theta into cos theta, and this component will be W sin, this component will be W sin theta into sin theta, that is W sin square theta, and this component will be W sin theta cos theta. And this W sin square theta will be balanced by the tension here. This tension in this string.
Yes, sir.
So therefore, that is the vertical acceleration of point A is arrested. It is for sure.
Yes, sir.
But now W sin theta cos theta will become an unbalanced force.
Yes.
And as a consequence, you can expect this to accelerate. You can expect this to accelerate leftwards.
Yes,
Okay,
sir.
so you can expect that to accelerate leftwards, and we are only retaining this, and since this component of the force is perpendicular, definitely this will cause this to accelerate, give acceleration in this direction, and that acceleration, as far as this point, this line is concerned, you can consider it to be tangential.
Yes.
Okay. So
Yes.
you can expect the alpha to be in this direction, and plus one more, this one I will call it as AA in this direction.
Yes.
Okay, so therefore the acceleration here will be, acceleration, tangential acceleration will be alpha into the total length of the rod, they have given it as L. So this will be L by 2. L by 2.
Why?
Because this total length of the rod is L.
Yes, sir.
So this is midpoint.
Okay.
So the tangential acceleration will itself become the tangential acceleration is alpha L by 2.
Yes.
And this component, what is this component? This component which is radial will become omega square L by 2.
Initially it is zero.
But omega is 0.
Yes,
So
sir.
therefore there will be no radial component.
Radial component. Yes, sir.
Okay, no radial component of the acceleration. But AA will be there.
Yes, sir.
So therefore our AC equation, AC bar equation will be AA bar plus what else?
Alpha L.
Alpha into,
L by 2.
hello,
L by
Minus alpha L.
alpha into L by 2.
It's in minus Jacob direction.
Huh?
minus Jacob.
Minus Jacob. Sorry, I have not written that. Okay, I'll write it in terms of. So now AC I will write it as AC minus J cap,
Yes, sir. Correct.
because AC has to act in this direction, because the force vector is, the weight vector is down.
Down.
So AC has to be downward.
Down. Sir.
Yes, sir.
Okay, and this AC will be equal to AP. Sorry, AC bar will be equal to AA bar.
Yes.
Yes.
So AA bar will be AA minus,
Minus. Yes.
okay, plus what else?
Alpha
Sir, alpha into L by 2.
theta.
So alpha into L by 2.
Sin theta.
Sir, directly we can't write. We need to resolve that.
We need to resolve it
Resolve that along your
along the two directions.
two directions. Alpha L by 2.
So therefore I will take this direction to be D. I'll take this direction to be D,
Yes.
and I will write here as CD cap. Just CD cap I'll write. Okay.
Yes, sir. What is CD, sir? Can
I have written, see this point is C and somewhere along this line I have taken this point to be D.
Yes.
I wrote CDK. That's it.
CDK.
Just I have written CDK. Okay?
Sir, AC will not be minus J cap.
Pardon?
AC will be between in the third quadrant, but not with minus J cap.
Why?
It has the horizontal and vertical.
No. See, listen. AC is they are what? Look at the definition. If the magnitude of the acceleration at the center of the rod is AC immediately after the thread is cut. Okay. Now, acceleration of the center of that point center C, acceleration of point center C is a consequence of the weight of the rod.
Okay.
And acceleration will always act in the direction of the force. Got it? So therefore now I have got the alpha L by 2 CD cap. Okay. So now I will have to write AC minus J cap. Okay, is equal to AA minus I cap. Now I will resolve this CD. I will take the component of CD along the direction of
J.
J minus J.
Yes.
I take it in the term of minus J cap.
Yes.
So therefore, I will have to write this as
Alpha
alpha L by 2
cos
cos theta
theta. Yes.
minus J.
J. Yes.
Okay. And the other vector I have to write. Okay. What will be that?
Alpha L by 2.
Yes. Alpha L by 2 sin theta.
Sin theta plus psi cap.
Plus I cap.
Plus. Yes.
Okay. I will get this like this. Now if I equate the J terms and these terms,
Yes.
I terms and J terms, I have to equate those. So I will straight away get AC is equal to alpha L by 2 cos theta. Got it? Hello?
Sir, what? So tell me.
Why should I repeat? I have written now.
Yes. Only J comes.
Only Jth component I have written. Okay?
Yes.
And as far as the AAth component is concerned,
It is equal.
AAth component is concerned, see, here I cap and this, they are only these two components will be there.
Yes.
And that will be equal to alpha L by 2 sin theta.
Yes. Yes, sir. Yes.
Alpha L by 2 sin theta.
Yes, sir.
Yeah.
Now, in this whole thing, they have not given alpha. Isn't it? Have they given alpha?
Alpha, sir.
Huh?
You can find alpha.
They have asked us to find out alpha. They have asked us to find out alpha, isn't it?
And even acceleration of it.
Even
A.
acceleration of AA they have asked.
Two things there.
They have asked here what?
Alpha and A. Alpha and A.
They have asked here, find the angular acceleration of the rod. Alpha they have asked and AA they have asked. Okay. So what is the value of alpha?
J cos theta by 2.
Okay. So what will be the alpha value of alpha? Alpha value will be 2AC. 2AC will go there divided by L cos theta.
Yes.
Hello, are you with me, all of you?
Yes, sir.
Yes, sir.
Because
Yes, sir.
they have asked us to find out alpha. Substitute the value of alpha in A here. So you see here 2AC by L cos theta into L by 2 sin theta. So here L by 2 will cancel and AC will remain. So you get here AC into tan theta.
Yes.
This will be
Okay,
Yes.
A. Okay, I think we are all right. Don't worry, all of you participate. Nothing wrong. See, unless we are all open-minded, we cannot learn. We have to be very open-minded. We should accept whatever comes our way. Then only we will learn. It's not that, okay, whenever we solve, it should be the right thing. Whenever we don't solve, we don't know, nothing like that. Our concentration must only be on learning. Our efforts must get converted into knowledge. Knowledge, knowledge, knowledge. Nothing else. No ahankar. Okay, no feeling excited, oh I got the answer. No feeling down because I didn't get the answer. Nothing should affect us. So I think we have all followed the right principles and we have done it, correct?
Yes, sir.
We have identified everything properly. We have not missed out any concept here. We have knit the concepts well and we have fully handled it.
Yes.
Yes, sir.
Right. Okay, fine. So let me just see whether the solution is also right.
Correct.
Solution as it is alpha we got 2ac by L cos theta, correct?
Yes.
And A also we have got. But
Yes.
what is the method that is being used here? Immediately after the thread is cut, all the forces in the rod are in the vertical direction. That is tension T up and this down.
Yes, sir.
Therefore, the acceleration of its mass center is vertically down. The mass center of uniform rod at its center, therefore, acceleration of the center immediately as the rod is cut is vertically down.
Yes, sir.
The end A moves in circular path of radius equal to the length of the thread supposing A.
Yes.
Supporting. Yes, sir.
Why does it move in circular path? It can move
Yes.
because that freedom is there for it. वो
Yes.
thread है ना, that freedom is there. That freedom is there. It doesn't have to move, but that freedom is there. Therefore, acceleration of AA at the end of A is in the horizontal direction. Immediately after the thread is cut. Yes, immediately after the thread is cut, it is AA is horizontal. That aspect we have also established.
Yes, sir.
Okay, after the thread cut and B is cut. So analytical method, AC bar is equal to AA bar plus alpha AC bar minus omega square. The rod cannot acquire angular velocity. Okay, this concept also we have taken into consideration because of the inertia. So therefore, we get here equating this. AC bar is split into two components. Okay, we have afterwards we have split it according to convenience. Here initially only we have split it. See, when the need and the necessity arose, we have done the analysis.
Yes.
We have not immediately split this. So we have done this equation. Yes, answer is correct.
Correct. Yes, sir.
Okay, fine. So superposition method. Superposition, this A bar is stored, this is stored, this is equated.
You solved combined.
We are not combined.
Sir, is correct, sir. Quantity will only move in circular path, sir. It move again, sir.
ಅದೇ ಹೇಳಿದೆ it can move, see he said it moves ಅಂತ ಹೇಳಿದ್ರಲ್ಲ, it can move ಅಂತ ನಾ ಹೇಳಿದೆ ಅಷ್ಟೇ.
Here it is.
ಅಂದ್ರೆ we should not think that it will move in circular path only.
Sir, see.
Correct, it will move, it will go in a arc.
Yes.
It will go in a
Only
arc.
tangential acceleration is there. And
But at the instant when you do it now, this acceleration vector will be tangential.
So,
Okay. So two strong problems I have taken so that all the concepts will come clear. Right, friends? So we will go to the next lesson.
Yesterday's summit.
Sir, that end A moves towards left, sir. Sir, it's like the rod is applying force on itself, no, sir.
Rod is?
It's like the rod is applying force on itself, no, sir.
No. See, see now, rod is, it applying force means the weight on the rod. See, the external force is the gravitational force, no?
Okay, sir.
As far as the rod is concerned, two forces are acting. One is the tension at point A and the other is the gravitational force. Correct? As far as the point A is concerned, the tension in the string will get adjusted.
yes.
Okay, and it will get adjusted. So there is no vertical acceleration as such. As far as that is concerned, because the thread is not going to elongate.
Yes, sir. Yes, sir.
Okay, and there is no force to push the thread up. Understand? So therefore, that will be there. Fine?
Sir, on doubt. Yes.
Yes, please.
Sir, if the acceleration of end is it is towards left, sir, then that means the center of mass of the rod will move towards left, sir. But the acceleration of center of mass is downwards. How will it?
No. Wait. Okay.
Yes, sir. Yes.
Okay. Wait. So you are telling acceleration of the
End is
Huh. So as far as the center of mass of the rod is concerned, it is here. The weight vector W is acting down. Okay, weight vector W is acting down. The rod is like this. The rod is like this. So the center of mass of the rod, is going to come down.
Yes.
Come down. Correct. What is the problem?
So like 10 days more towards left.
See, listen. It is the acceleration at that instant. I said it is to the left. It is not at displaced to the left. Point number one. And point number two is we have also got to take this force. The tension here is also external force acting on this.
Okay.
So that is balanced.
This is balancing only the vertical component. The vertical component. The horizontal component. See this force vector, whatever it is there, no. Here at this point, I have resolved this into two components. This component and this component. So this component I further take here. It is going to push the rod.
Yes,
And this component I resolved it into two components. One this and one this. So this component is balanced by the rod. But this component is not balanced by the rod.
Yes.
Okay. See, obvious no. See, now this point as you see here, this point is going to move like this, no. So it is going to come down also and to the left also.
So how will you?
So, but how if it is accelerating downwards, how can it move towards left?
No, that's what you are not taking this. You should also take this force into account, no.
Sir, even if we take that force, sir, like acceleration of center of mass will still be downwards.
Yes.
No, see, that's what we said. No, acceleration we told is AC is down only, no.
And it's because of
See, AC. See, we said AC is what I wrote. AC as AC minus J cap, no.
Yes. Yes.
See, I did not. For AC, I have not added any ith component.
Yes, sir.
The center of mass of the system has come down only. It has not gone to the left.
Yes, sir.
Fine.
Yes, sir.
See, at the instance when it is cut, no, there is acceleration vector. But I didn't say that AA is displaced. That is why you see when he said that rod will go in a circle, I said it can go in a circle. It is not going in a circle.
Yes, sir.
Okay, that push is only.
What will happen to that A vector?
Nothing will happen. There will only be acceleration at that point. But there is acceleration at that point, but it will not go. It will not. See, there is no. See, the acceleration vector is there. See, when force acts on a body, what will happen? See now, I am applying force on this wall. What happened? Nothing happened. Why? Because it is not free to move.
Yes, sir. It's constrained.
It is constrained.
Yes, we do.
Yes, sir. Acceleration and action, but displacement will not be the same.
See, Manodama, acceleration is an independent vector. Velocity is an independent vector. Displacement is also independent vector. But at times they all get related to one another.
Yes.
Understand? At times they all get related to one another. That's what you have to see. And when you say there is acceleration, see, that doesn't mean that there has to be displacement. For example, centripetal acceleration is there.
Yes.
Okay, see, whenever the acceleration vector is perpendicular to the velocity vector, what will happen? Only the direction will change.
Yes.
The magnitude will not change. Correct?
Yes, sir.
So therefore, there you see that point is accelerated. Okay, but that doesn't mean that, and we are considering that at that instant only. See, the problem here ends there. They are not telling at the next instance what happens.
Yes, sir.
Understood? And as far as we are concerned, the two active forces acting on the rod. What are the two active forces acting on the rod? Neela, what are the active forces acting on the rod?
It's where, sir?
its weight and tension.
Tension, yes.
Its weight and tension, and both are along the vertical axis.
Yes.
And if at all the center of mass has to move, can only move along this axis.
Yes, sir. Yes.
And therefore, I immediately wrote AC as AC minus J cap.
Yes, sir.
Understand? So therefore, the center of mass has only transited along the vertical direction. Transited means it is in the, if at all the center of mass changes, it will be only in the along the vertical axis.
Yes, sir.
Got it?
Yes, sir.
Okay. So shall I proceed?
Yes, sir.
Yes. Here I can say acceleration is also in the direction. It acts in the direction of force.
Always, man. That is
So
first law of Newton. Huh? So only. So only. Right. Shall we proceed?
Yes.
Yes, sir.
Yes.